Okay, today we're going over 11.2 arithmetic sequences. So this is moving on from 11.1, and yesterday we talked a little bit about different types of sequences. So today we're going to focus on arithmetic sequences. Okay, so in an arithmetic sequence, the difference between consecutive terms is constant. So it has to be the same every single time. So, for example, if we're looking at, say, even numbers, 2, 4, 6, 8, and so on, then we can see that every time to get to the next one, we're adding 2, which means that this is going to be a constant between each one. It's constant. And the difference between the consecutive terms is constant. So you're adding 2 each time. So this difference is called the common difference. That's what we're going to have it as. And the common difference, we're going to use the variable d for the common difference. So to find the common difference, for ones like this one is pretty straightforward. You're adding 2 each time. But the other way you can look at it is, we know that this is the first term here, right? And we write that as a sub 1. And this is the second term here. We write that as a sub 2. Okay? So to find these, and the next one is a sub 3, right? So to find the common difference d, what you can do is you can simply take the second term, a sub 2, and subtract the first term, a sub 1. So if we look at this example, a sub 2 is 4, minus a sub 1 is 2, and 4 minus 2 is a 2. And you have to make sure that it works every time. And if it works every time that you're adding 2, then it's a common difference, and therefore it is a arithmetic sequence. Okay, so let's take a look here at identifying an arithmetic sequence. So is the given sequence arithmetic? So here's the first one that we have. And we have 2, 4, 8, 16, and so on. So to get from 2 to 4, we can add 2, or we can multiply by 2, right? To get from 4 to 8, we can add 4, or we can multiply by 2. So here we're not adding the same number every time. What we're doing is we're now multiplying by 2 every time, times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So this is not an arithmetic sequence. Not an arithmetic sequence. And tomorrow, or in the next lesson, we're going to go over geometric sequences. So this sequence is actually a geometric sequence, and we'll go over that more in the next lesson. Okay, here we're looking at the pattern that a golf ball makes. So if we look here at the circles that the pattern it's making, it has 6, and then 12, and then 18. So here, to get from 6 to 12, we can either say, okay, I'm going to add 6, or multiply by 2, right? So we want to see, can I add 6 again and get to the next term in my sequence? And we can. So we're adding 6. Or you can use that little formula that we learned before, which is taking the second term minus the first term, which is 12 is your second term, 6 is your first term. So therefore your common difference d is 6. And therefore this is an arithmetic sequence. Alright, so moving on, we're now going to look at how we can write equations. So we talked about the difference between a recursive formula and an explicit formula. So for the recursive formula, we need to know the previous term. For the explicit formula, we do not need to know the previous term. The previous term is unknown. So for the recursive formula, all you're going to do is you're going to have a sub 1. We're going to say that's a. It is going to just be a given value. So we're going to take the previous term, right? A sub n minus 1 means the previous term. Okay, so we're going to take the previous term and add d to it. And we just said that d is your common difference. So this is the recursive formula for an arithmetic sequence. This is only for an arithmetic sequence. So a sub n equals a sub n minus 1 plus d, your common difference. Your explicit formula is going to be a sub 1, which a sub 1 is always your first term. Okay, a sub 1 is your first term. D is your common difference. And then n is whatever term you're trying to find. And that's the explicit formula for an arithmetic sequence. Okay, so let's take a look here. We can use one for this problem. It says, suppose you participate in a bike-a-thon for charity. The charity starts with $1,100 in donations. Each participant must raise at least $35 in pledges. What is the minimum amount of money raised if there are 75 participants? Okay, so that means that we're starting with $1,100 in just the charity donations. That means that this has no participants, 0 participants. Then we would add 35 to get to the next one. So plus 35, and that's going to be 1135. That's with 1 participant. So this is the second term, but it's only 1 participant. We add 35 again, we get 1170. This is the third term with 2 participants. So if we want to see how much money is raised, the minimum amount that's raised with 75 participants, that means that we would actually be finding a sub 76, because the first term has 0 participants. The second term has 1 participant. So therefore, if we're trying to find the amount of money raised for 75 participants, that's going to be the 76th term. So what we're going to do here is we're going to use the explicit formula and find a sub 76. And we're going to use the explicit formula here because then we don't have to list all 76 terms. Okay, so here's our formula. We're going to find a sub 76 is equal to, our first term here is 1100. Our common difference d, we're adding 35 each time. N is 76, because that's what term we're finding, minus 1. So we have 1100, we're using order of operations here, 35 times 75, and then we'll multiply that out. 35 times 75 is 2625. 2625. We'll add 1100 plus 2625 and get 3725. And that is going to be the minimum amount raised if we have 75 participants. It's saying the minimum because maybe some people chose to give more money than just the minimum $35 in pledges. Okay, the next thing is going to be looking at the arithmetic mean. So the arithmetic mean is the average of any 2 numbers. And this is going to be helpful because, so the average is just taking the sum of the 2 numbers and dividing it by 2. And the reason why this is going to be helpful is because if they tell us it's an arithmetic sequence, then we can find the arithmetic mean to find the missing term here. So I know it's an arithmetic sequence, so to find this number here, the missing term, I'm just going to find the average or the arithmetic mean of those 2 numbers. Okay, that is only if they tell you that this is an arithmetic sequence. So we have to know that before we actually go ahead and find the missing term. Okay, So we're going to take 84 plus 110 and divide that by 2. That will give us 194. And then we'll divide that by 2. And that will give us 97. So this number right here will be a 97. And you actually can check that to see if it works out. So you could say 84 plus what number is 97? That's 13. So I can add 13 here to get to this number. And then I want to make sure that when I add 13 here, will I get to 110? And yes, that's correct. Okay, so if we want to find the missing term here, then we're going to take these two values, 24 plus 57, and divide that by 2. So again, we're doing this because they're telling us that it is an arithmetic sequence. Okay, so this is going to be 81 divided by 2, which is 40.5. So this one right here is 40.5. And then this one here, we're going to just set it up the same way. So write an expression for the arithmetic mean of a sub 6 and a sub 7. Okay, so that's just going to take these two, and you'll take a sub 6 and a sub 7, and you're just going to plug it into the same exact thing here. So you'll take a sub 6 plus a sub 7 and divide that by 2. We just plugged it into our formula. Okay, and then there's the Fibonacci sequence. This is just a different type of sequence. It's not an arithmetic sequence, so we're not going to go into that too much for this lesson today. So that's all for today. Thanks for listening.